Any decent attacker will look at the source of a page before attacking, and when an attacker sees this, he sees red, all of a sudden he says, man, this application developer is stupid. He forgot to remove the backdoor of his admin. Don't tell me the application developer is so stupid to have this, and if I remove it, I become admin. This is what the attacker will think. So straight away he will remove the comment, and he will run it, hoping to get admin, thinking that the application developer is an idiot. As soon as he does this, we know he attacks, obviously. A normal user never look at the source code. Do you look at the source code of application? I mean of HTML pages? You have something else better to do most of the time. And you can create as many booby traps as you want. Classic one, imagine the guy is not logged on yet, and you know your administrator is called Fabrice, for example. If the guy tried to type admin, obviously he doesn't know the admin is called Fabrice. Obviously he's not my user. Obviously I don't want to entertain him. Now imagine you're logged on as Joe, and you try to change your URL to /admin, which is typically where the admin functionality is. You're cheating again. Who asked you to enter the URL directly? You're supposed to click. So whichever booby trap like this are very easy to put in place. And they are foolproof. They are really foolproof. A normal user will not try to go /admin. If he does, he's trying to fool you. But we have a bunch of other classic injections that you could detect pretty easily. You could detect LDAP injection. This is one of those that people don't really talk about. It can be very fun, especially on systems where they use LDAP for authentication. A lot of old attacks are basically designed using by injecting some carriage return characters that don't get handled properly by the attack. It's the same. Who has a carriage return in his name? Unless it's more than 100 characters long and too big to put on a form, your name stands on one line. So we could detect this kind of things. We could detect as well shell command injection, XPath. You have some excellent talk on XPath last year. And COBOL, don't forget about COBOL. Of course, we can always check for parameters that are not supposed to be there in the first place. Browsers do not add parameters on their own will. They don't have a will. So if you see that you have additional parameters, obviously the guy is trying his luck. You'd be surprised how many times this kind of additional parameter work on an actual application when you attack. You try your luck using one of those and you get admin. It happens all the time. So of course, an attacker will try this. If an attacker tries this, we'll flag him. Role bypass. Let's say I'm logged on as Joe, and in my menu, of course, I have a normal menu. I don't have the administrative menu. And I try to go directly to an administrative kind of function directly by typing the URL. I'm cheating again. Easy to detect. And then if you try to modify any validation that we've put in place for you, any restriction that we've put on you that a normal user would follow, whichever you try to bypass, basically, if we can detect it, we will, and we will flag it as such. So now what's interesting is that we can put a score on each and every of them. Let's say the booby trap one is you put the maximum score. A normal user can never do it you cannot trip on it by mistake. Okay, who pressed on view source by mistake? Nobody. Who pressed on view source, uncomment, there is admin, and then send by mistake? No such thing. Or even better, who install an interactive proxy, configure his browser to go through it, modify the thing by mistake? Yeah, I'm waiting. So basically, whichever method that you can think of that I didn't list here, there's probably some more, but those are classic ones that we always use when we attack applications. You could add them in such a framework if the framework is designed properly enough to be modular, to accept plugins and things like this. So you quickly realize that such a framework would be pretty easy to do. It takes some time to write, but then it would be pretty effective. Whenever you try, if you just trip on something simple, that's it. We cut your account right away. So you can't even try further. Once your account is cut, you can still call the bank or call the government if it's a government application and say, hey, my account was, cut. And then they will investigate. So of course, if you're an attacker, you're not going to call the bank and say, sorry, my account is cut. They will investigate and you will go to jail. So you know better. But at least you will stop attacks pretty easily like this. Input validation, that's the holy grail of any application security. You hear this in so many other application security talks. I will not spend too much time on it. Basically, the goal is to really validate that the input you're getting from the user is really what you expect. If you expect a date, please, by all means, verify it's a date. It's not difficult. We know the rule for dates. There is no 30th of February. Try harder. Things like this, but people don't verify. There's a lot of application when you enter 30th of February and that's it. But this is not an attack, so I don't really care. If you don't verify the 30th of February, maybe I can do a buffer overflow on it. Maybe I can do other things. If you don't verify, we can perform all the attack beforehand. In a nutshell, if you do your input validation properly, there is almost nothing we can do to attack your application. Again, this framework is just here to stop you from trying in the first place. Okay? This framework, there is a big caveat. This framework will not fix the problem. It will prevent you from abusing this problem and attack the application, but it will not fix the problem. The problem will still be there. The framework will shield you from it. It won't fix it. So to continue with input validation, you want to verify phone numbers. In most of the countries, there are very strict rules for phone number. The amount of digits, and which digits can it start, and things like this. Sometimes it's even coded by region, the first 2 digits for a particular region, and if it doesn't match with the region of the guy, then you know it's cheating. Things like this. Same goes with zip codes. Same goes for amount. Same goes for absolutely every kind of input. Sometimes you don't have any rule for a particular input, like names. You have very few rules on names. Okay, but you have at least one. You know that there is a character set. Let's say it's a government application when you have, let's say, only Malaysians, for example. So Malaysians, you will have typical Malay names, typical Chinese names, typical Indian names. So you have a few char sets only. So you wouldn't accept other char sets, for example. And if the guy has really a name with a different char set, then you force him to Romanize his name. I give you an example, a Russian guy here, for example, you would force him to use Roman letters instead of Cyrillic. Like this, you can input validate properly. Anyway, if a Russian guy opens an account here, his name on the system will already be Romanized because the backend doesn't support Cyrillic. So you must check absolutely everything. Whatever you can, you do it. So now the advantage of this framework is that you will not have to do the input validation yourself. You will tell the framework what is it that you expect, and the framework will validate it for you. Like this, you have no more excuse. You cannot forget it. The problem with input validation is that people always put some form of input validation, but they always forget some. And guess what? You know, we are paid to find out exactly where they forgot, and this is exactly where we will attack. So, of course, we could already put some basic generic input validation inside this framework. Like we could put amounts are amounts, whatever application you use, an amount is an amount. There's never more than 4 digits in an amount. Most of the time it's 2. Zip code is never more than 8 characters, and so on. So we could create some generic validation objects that you could already use. And then if it's not enough, we could either provide you with callbacks. In other words, the framework will call back your own function to verify. Or we could use object-oriented technology and use inheritance, whereby you would specialize a generic object to verify exactly what you want it to verify. Am I going too fast? I lost everybody. Again, this is pretty simple, but if put all together properly, you will stop attacks. You are not doing it at the moment. Like I said, at the moment, most of the applications do proper input validation when they feel like it, which is very rare, in other words. And when they do, they still let you bang on the door. I don't like people banging on my door. So now, miscellaneous validation. This is where we're going to check for all the interesting attacks, as far as I'm concerned. Whichever attack that involves stealing money, involves perverting the functionality of an application, logic flows, could be verified here. So this is a little bit the problem with this framework, is because the framework has no generic way of doing it for you. So it means, in other words, here we will just provide you with a hook for you to place, a placeholder for you to place all your logic validation. This is here that you will have to check whether it's your account or not, whether the guy is authorized or not. We can't do it for you. I mean, I'm talking about banks here because everybody understands, so that we could almost do it for you. But then, what do we know about government processes? Like example, in Singapore, when you want to buy a car, there's a complex process. You need to get a certificate of entitlement. You need to pay for this first, sign up there then, and if you have all this then, you can get your car. So now such an application maybe could be pivoted to bypass some of the steps, for example. So all of this is not generic. We can't do it for you. So it would have to be done at this layer. Business logic very much depends on the logic of the application. What is the business process? What is the application designed for? Advantage is, of course, we would typically be using object-oriented techniques, so you would have less code to write, but you still have to write some. And this is exactly where the problem will still be. This framework is not going to be magic. As in, it still could be magic because even an experienced attacker may trip on booby traps and things like this. But it may not prevent properly logic flows. Why? It's because you may not know your own logic. You may not know your own business process. This is a classic problem. Most of the developers are just given a blueprint saying, hey, you do this. Okay, it needs to transfer from this account to this account, and that's it. We don't give you more information than that. So developers just do the strict minimum that they are told. Remember this. Developers are lazy. I used to be one, I can tell you. We don't do more, not less, just this. So if you don't tell the developer what is it supposed to be, what's the expected behavior and things like this in very detail, the developer will just do it anyhow. And then, of course, even if you have such a framework, if the guy doesn't bother to put checks in place, the checks are not going to be there. Scoring and calculation. This is very important in an enterprise application. You always want to have segregation of duties. Different people have different strong points. A security administrator, for example, knows nothing about application, but he knows how to take action if there is a problem and things like this. He doesn't know how to code, basically. He knows about attacks, but that's all. An application developer, on the other hand, is supposed at least to know about application security. How good the word would be if that would be the case. But now imagine they know about application security, they wouldn't know how to fine-tune the application security to the particular environment. So the advantage of this scoring system is that we have a clear cut between the application itself and its security and the prevention and action side of the security. In other words, the developer just bothered to create his application securely, and then that's it for him. The scoring part will be taken care of by the security administrator. He will be the one who decides, okay, for this attack, I give this score. For this attack, I give this score. And if you have more than this score, then I send an email. If you have more than this score and you come from a dodgy country, for example, then I call the police. If you come from that country, for example, I don't bother. Like if the attack comes from Korea, I don't even want to bother, because no point. You can call the Korean authority and they won't even listen to you. They have too many attacks. It's not their fault. They are being used as a stepping stone. So they receive so many complaints that when you have an attack from Korea, you might as well just drop it. No need to take action on it. So in other words, it's really the security administrator that will decide the flow of the detection and action. Very important. Like this, everybody do what they know best. Obviously, we have to log and report. This is something most of the applications are not doing properly. I'm sick and tired of doing application security, asking after 3 days for the log of the application, and the developer tell me, here you go, and I have a file of, I don't know, 512 bytes, 2 lines of logs, after, I don't know, 50 successful attacks, after I've already stolen money, after I already crashed the database server twice, no logs, none. Or the other way around, with all the same attacks, I have 10 million entries, with half of them being syntax error from